What? Hello, GM speedrunner is described in the description of the video. Okay, below the video, the description. So far we're having fast internet. Seems also to be doing that every time again. Right, so let's say position.h. No, just want to have the data vertex position.h. Oh, that's weird. Did I change the shader code? I must have, but I cannot remember. Oh, I did. Okay. Let's use the div. Divs are always more clear, I think. That would be this one. Let's see, instead of using one vertex buffer, vertex data, remember one type corresponds to one vertex buffer, we could have used, say, vertex position and vertex color, separating the positions and colors into two vertex buffers. I think that these should be not there. Separating positions and colors into two vertex buffers. Vertex position.h full file. Why? No, why not? And then have two vertex buffer generators, for example, position and color instead of triangle, that only fill respectively m position and m color. Respectively. Define both in your window class, so instead of triangle you have position and color now. Add both to m vertex buffers, trivial, and change the, not then, the order doesn't matter. And change the shadow code. Let's be consistent. Use a column there. To use vertex position m position and vertex color m color. Yeah, let's move that up, I guess. Here. Yeah. I think this is working, right? Top. Seems to be working. So get status. Rename the shit out of it, but the div still works. How cool is that? Do git add stuff. Wait a minute, I don't want to commit this. I already have the diffs. I already renamed it. Shit. Hey, just as, yeah, man, do just, you know, what I meant was spend time on learning things that interest you. But I was assuming that you are so smart that you don't have to do anything for your study. I mean, if you say the only thing I have to do is play basketball, then I guess that just the actual work that is required doesn't take up any time. I'm not sure what study you did. I never did anything in the high school. Well, I mean, I had to study for languages, but not for physics or mathematics and stuff like that. But that changed in university. I'm kind of glad that I had to study hard on languages, like French and German and all that stuff that we had to learn. Because at least that way I learned how it was to study, if you get what I mean. If you get used to not needing to study at all, then you're gonna have a very hard time once it gets necessary, and it will get necessary. I guess motivation is the most important part. You really have to sit down like, aha, now I'm gonna, really get behind this and understand it and become the best in the whole school. And then go beyond that, because there's probably more interesting stuff that they don't teach me. And that's a better point of view, I think, than thinking, oh my God, I don't want to spend time on this. Why do I have to do this? I want to do something else. If you get what I mean. It's a mind setting. Yeah, okay, and the problem here is that I already renamed some stuff, and then that's hard to undo without getting into a mess, I think. Although I probably could just rename it back and still keep the changes inside of that. Probably. I guess it just feels scary because I don't know what exactly is happening behind the scenes. But that's an unreasonable fear. Not understanding should not be the same thing as being scared of it. So I'm just gonna do what it says. Restore staged. And then which file? Excuse me. Which file? Let me try that one, because it doesn't exist anymore. That worked. Okay. Do the H. And we do that one. Vertex data is also gone, right? Yeah. And now my status looks like this. Change the committed. We have new files. Yeah. Also have to get rid of those then. No, wait. Position.cxx is still there. I didn't move it back. So I did get a miss. It did become a miss. Let me try moving it back. Nah. Arg. Arg. Okay, this is absolute miss now. Absolute miss. I'll have to try to fix it anyway. Let me get rid of the deleted, I guess, by just moving them back. So that then becomes that. And that becomes that. And that becomes that. No, I still have new files. And I've deleted files. Deleted? Did I already commit it before then? Yep, I did. So I already had commits. That gets worse and worse. Okay, we'll move it back. New plan. Oh man, this is bad. How can I undo this on stage? I have to get rid of this. I still have stuff checked into the index and not committed. Git normally should pick up automatically when something is renamed. And it did. And then I did it on stage, and now it doesn't see the rename anymore. The problem is, of course, that it's almost the same thing. So the triangle here looks very much like the color and also very much like the position. So one of them could be seen as new and the other one as moved. But then which one to pick, I guess. And the same holds for the vertex. Vertex data is split into, is copied and changed, both. So maybe I should just forget about the move, I don't know. Yeah. Or I can move one of them back and then use git move again. I think that might work. But that then should be done afterwards. So right now everything is uncommitted changes. And I want to make a new branch. How does one create a new branch? They allow 2 vertex buffers. Just switch to a new branch. Git switch create hello. That was the name or what? Hello 2 vertex buffers. Yep. Okay, so then now I can do some stuff like if I now just move, let's say, position back to triangle. So position.cxx becomes triangle.cxx. And position.h becomes triangle.h. And position vertex position.h becomes vertex data. Now we don't have deleted files anymore, but we have new files. And then I do git move, and then I move them back. Yeah, we renamed again. And these are new then. And then That worked. Git commit minus everything. Yeah, I thought it was moved, but it's not doing it. Oh well. And it still works, right? Okay, so next thing. We're completely done with this. Just new commits, so do git commit minus everything. Oh no, the following submodule path contains changes that cannot be found. Yeah. Shall I do this? Why not? Excusez-moi. No, strange. Maybe you have to push this. Git push new branch to GitHub. I don't know, looks a bit old. That's what I was looking for. So it is push minus u origin, which is GitHub. Origin my ass. I am myself the origin. Your branch name. Well, that would be the current branch. Which is, I have no clue anymore. Well, it was hello 2 vertex buffers. New branch. Not even sure if I pushed the other one already. Probably. Yeah. Well, with that finally done, I don't understand your sentence. How are you? How long time I have to learn for get first work? Yes, absolutely. In the meantime, I have to figure out what I want to do next. I think I'm done with vertex buffers totally. Yep, we're gonna go to uniform buffers, I guess. Although I'm not sure, that's why I said I guess. So there's something else that would be at least as interesting, like push constants maybe. This guy doesn't even talk about push constants, well, at least not here. Nope, push constants have been eradicated from this site apparently. Strange. Well, I need a kind of an example that uses push constants as well then, which I don't have. Well, I have it, but I need an example of uniform buffers too then. Let's see what this guy is doing for the uniform buffers. A whole matrix. think I'm gonna add IMG first. I could just add IMG to, let's say, to the hello vertex buffer. Let's add a simple IMG. Simple IMG. What is a simple IMG? Does Texas have an IMG? Coordinates. I broke stuff. That's also interesting to fix, of course. Why is this broken? Which is broken? I'm having it's okay, my uniform buffer test. That still works. I want to do this stats window here. I want to add that. But I also, so this is my uniform buffer test. But yeah, let's add that. And what was the other one called? Frame resource count. It also still works apparently. Well, so it's just my texture test that crashes. Got to fix that. Paranoia check. I hate encountering that. We shouldn't be trying to insert something with the same stage flags and binding. I feel I was in the middle of something and I never finished it. Pretty sure of that. And I think that we are crashing because I never finished it. Difficult. Very difficult. Okay, this tests the following thing. Sorted bindings and flags. Find inside that container something that has the same binding and the same stage flag. And then if that is found, then we crash. So we're looking for element binding and element stage flags in this container. And element here is whatever we pass, so that's what we run over. Rather than, I should look at that, which is being printed here. So we should be able to see this debug output and then see twice the same value there. For the same container, aka the same this pointer also. Yeah, pretty sure I already looked at this. Deja vu here. Let's just see where we crashed. So I crash here, and that is this pointer is failed. Wait a minute. Where's my this pointer? Oh, it is not the this pointer. Wait. Entering. That's the this pointer. What a horrible color. My god, it's unreadable. Okay, anyway, binding 0, descriptor type, combined image sampler. So it was about the stage flag, the fragment shader. So binding 0, fragment shader. Is that it? I think so. With that this pointer. That's a different this pointer. That too. That too. That too. And then we got to the bottom. What? Gonna run this again because the color is just too horrible. Can also search for entering. It's probably better. And then this pointer. Nope. Nobody gets it. Unless this is it. No, now we are at the bottom. My god. Why so difficult? It's just inserting the exact same thing everywhere, right? Exact same thing. Binding a 0 in all cases. It's always a combined image sampler. And always an array of size 2. It's always the fragment shader. That's always 0. This value is, so there's always a -2 here for some reason. But this pointer is always different. Yet it chooses to stop at the 5th call. I think we need to know what's going on, and that is probably horribly difficult. Horribly difficult. So this is where we crash, and we get here from restore descriptor set layouts. That's frame 10. I will look there. Yeah. Okay, let's break there and then so this is the first time we get here, second time, third time, fourth time, fifth time, crash. No, it didn't crash yet. Didn't crash at all now. Did we warning core dump? We do core dump. We core dump even when we do it step by step. So we run again. First time we get to the assert, second time, third time, fourth time, fifth time. I'm pretty sure this one was crashing. If I do next, it should have core dumped, but it didn't. Or I'm still in the assert. Wait a minute. I should probably try to break it afterwards then. 37, continue. Yeah, that core dumped. So test that again. Oh, I did add breakpoint 3. So we have a disable 3. We'll run from the beginning. And I think I'm doing continue 4 times. And enable 3, continue. Nope. I don't get that. If I continue 4 times, it's like the that would be the fifth assert, fifth time that we get in an assert. I don't get why. Now it stops at 47 again. It's not super reproducible. It's not super reproducible. But we did core dump. Again in the same line, at least. Some point it happens apparently. Okay, I'm gonna run over on the beginning. Now, the first time we get here, it is from so we're doing call to the pushback descriptor set layout binding called from generate descriptor set layout bindings, which in turn is called from preprocess 1. Continue, backtrace. So that's the same thing. Let's highlight this one. Also we get here from generate descriptor set layouts bindings called from preprocess 1. So that's twice the same thing. Continue, backtrace. Also generate descriptor set layout bindings called from preprocess 1. Continue, backtrace. Also generate descriptor set layout bindings from preprocess 1. No, continue, backtrace. Now it's from restore. So no longer from generate, but now we get there from restore descriptor set layouts, which is called from preprocess shaders and realize descriptor set layouts. And the other one is that also from here, preprocess shaders and realize descriptor set layouts. So the previous one was, as if we can find that back. We can. Yeah, also. So preprocess shaders and realize descriptor set layout is a common point. And then in one case it calls preprocess 1, which calls generate descriptor set layouts bindings, and then we get here. And the other one calls instead restore descriptor set layouts, and then we get there immediately. Now the first time we go through restore descriptor set layouts, we did not crash. Backtrace. This again a restore. That's ought to be the second time then. And now we crash. So the second restore crashed. Let's run again. Backtrace. Well, that's not a restore yet. So continue. 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 This is restore. Continue. Again a restore. Continue. No crash. Still no crash. Gotta be kidding me. The restore can be called a lot of times, and then one of those times you crash, but not immediately. Yeah, now we crash. I'm gonna put my breakpoint, I think, in the restore itself. Delete all breakpoints. Yep, break. Let's break there and from the beginning. And then you do continue and no crash. Sick abort. Looks pretty much like core dump. Yep, here's the core dump. That would be the first call. Run again, yes. Continue. Core dump. Aha. So we do it this way, it's just every time the first time. The first call to restore goes wrong. Run, yes. Continue. Well, often anyway. Not now. Continue again. Now what happened? Well, I did continue after. It was already killed. I just missed the core dump, I think. The core dump was way up. So it's really the first time. Oops, let's try that again. Continue. And then pthread kill implementation. Yep, yes. Continue. Kill. Pretty reproducible, it seems. Kill. Okay. Now, if I do run, yes, and we do... I am now in thread 4. So if I do continue, we stop in 4. Run, yes. It's definitely the same thread, right? I mean, thread 8, and so on. Okay, run, yes. So at this point we are going to add something that is already there. What am I going to add? First restore. Well, the same thing as always. Let's just do a next here. Next. Restoring. Do we get this pushback? This is binding 0. Is this the crash? 352. That is the crash. Do a step here. So it switches from being a member function of that, and then it simply calls pipeline factory pushback script set layout binding with M binding, which is actually part of the current object, so that would be this one. Then we have our binding, and then the M stage flags is also from that object. So it is this object that already exists in terms of binding and stage flag. We're calling that on a pipeline factory. Push back to descriptor set layout binding. Yeah, it's super difficult. Really. I think the reason that you see this twice, and this meaning whatever is highlighted, plus the index 0, is because we have two pipeline factories. And I think I need two pipeline factories in order to reproduce this bug. This fucking code is so difficult. Just it has to work, and then nobody has to ever look at it again, if you ask me. Oh, this is my memory. That I haven't looked at it in a while, and now it's like no idea what's going on. So it's really bad that it doesn't just work. I have to look at it again and understand it again. Maybe you should write documentation about it. So they start analyzing and then write up a documentation page for the documentation website. Explaining, what I'm analyzing. Then at least I have documented how it works, right? That would be then some kind of appendix or something like that. Internal document-ish thing. It's probably needed anyway. Otherwise, at some point, nobody will understand anymore how this thing works. Got to document it. Anyway, the only thing I can remember here is that, let's say, if you have shader template code, then I must generate the declarations for shader variables, which happens while pre-processing. And then it's compiled, and then we use it. And now I decided to say, if it's compiled, I don't want to compile it again. I mean, that makes sense. Therefore, I don't want to pre-process it again, because why would I pre-process it when I'm not going to compile it, right? But by not pre-processing it, if you have two different pipeline factories and one of the factories encounters an already compiled shader, but it skips the pre-processing, then it's just missing information that it still needs to generate the layout of the pipeline, basically. Therefore, what I did is, or try to do, is to cache that information. If it's a pipeline factory just pre-processed something and compiled it, then it caches the information that will be missing in another pipeline factory that encounters the same shader. So it doesn't have to pre-process it, but it still has the needed, still has the required information. That's the idea. So you see that back here. We run over all the shaders that need compiling, and then it turns out that one of them is already compiled. So I skip it. But we call these two things here, which then restore from the cache the information that otherwise we would have gotten during preprocess. And if I don't do that, then well, I just don't have enough information, and things will go wrong. But now it turns out that things go wrong anyway. And we have to figure out, in order to fix that bug, we have to figure out what is going wrong, of course, and why it is going wrong. And preferably get a much clearer overview of what the F I'm doing here, so that I can avoid any other lingering bugs that might still be in it. But in the meantime, I've got everything about it. So if I look at this code, I see the same as you. I just think, well, who wrote this? And that makes it pretty difficult, I guess. I need a complete overview of the whole thing. Otherwise, I cannot fix it in a way that it is bug-free afterwards. I think this bug that's in it now comes from the same thing. I just never had an overview to begin with, because it's more complex than I can have in my head. At my age, I would say. I don't know how simple it is. I don't know how simple I would have called it in the past. I don't know if it's more complex than I ever did before, or more likely, and that it's just getting so old that I think that things are difficult that I used to think were not difficult. Either way, let's start with commenting this out and then see what the error is, so I know, what it is trying to accomplish, at least. I think that this is the only place where I'm calling a restore from cache. At least that really should be the case. Totally. And then the other one, the restore, that one should also be the only place where I call it. Yep. It's just CarloWood and declaration and definition, and this is where we call it. So if I no longer call it, then what happens with that TT thing? I hope it won't work. It works. It just works. So that's double annoying, I guess. That means that it's trying to restore something that it already knew anyway. And that's actually kind of the, what the assert is saying, right? You're trying to add something that it already has. Okay, I think I need to identify what it is, what exactly that data is that it already has, what it means, how it comes to, how it is generated while preprocessing something, why it is needed, and then where and when it is stored, especially when, and then finally, why it happens that I try to store it again as a restore while I already have it. Maybe should have written that down, that list. Let me go to Discord. I have a development. Development channel. So what did I say? So to figure out what the information is that is stored. Why it is needed. How we get the information while preprocessing. When it is stored while preprocessing. No, well, not it, but when the data is stored while preprocessing, and that then we try to store again as a restore. Yep. So what information is stored? Why do we need it? That gives me at least a little bit of feeling of how what. And then where the information comes from while we are normally preprocessing stuff. And then I'll probably always cache it. But now it happens that we restore it. So I want to know when the data that we tried to override while restoring was already stored. So that's the last thing is the actual bug. Just involving, I guess, some kind of a race condition. Let's begin with the first thing. What information is that is stored? Yeah, now it just works. It's a good question though, if it keeps working, if I just run it several times. That was like reproducibility. So what we are doing here, this application, by the way, it has 4 squares or rectangles with textures on it. And they begin gray, which is also a texture, a 1 pixel by 1 pixel gray texture. And then I set a timer, and when the timer goes off, I say replace the texture on that square, on that rectangle with another texture. So the reason that it is so slow is simply because of a timer. And the timer has a reason. I've got which though. I think the timer is especially because I want the texture to be updated like later, you know, not from the very beginning, which is different. What you do see, however, is that those 2 textures appear at the exact same time, right? It's just I replace the texture. It's more like these 2 show the same texture, and then when the texture has arrived, as it were, it can only really be shown. But it's more like the texture is there, not that I really change the texture on this rectangle and then afterwards that one. It's more like both point to the same texture, and then suddenly they point both to another texture. I think it's pretty reproducible. Okay, let's change back what I changed last. That is, I commented this out. Now, since I don't need either of them, I might as well keep this one comment it out because that one's the one that goes wrong. Or I can test if I just comment this one out, that it still works. That would also be interesting, I guess. Yeah, it seems that that part works. But it isn't needed. So I'll comment this one out then, and this one commented this one in. And now it should crash. Post bunny. Like textures, crash. Yep, that's that point. So that definitely crashes. And I wanted to run it in a debugger, I guess. Run. Okay, the first question is what the information is that is stored. What is the information that we store? Well, that would be the one that we find back, I guess. Well, it's a descriptor set layout binding. Haha. But let's add a little bit more detail. It is information that is stored in sorted bindings and flags. It happens to be a vector which stores stuff. Stuff is probably some kind of a Vulkan type. Also binding flags, so not a vector. I'll just have to look for sorted bindings, I suppose. Documentation. There's something. And there's another one. Oh, this is a comment. Good. So there's only one. That's the one. It can hardly be. Because this is only storing a VK descriptor set layout binding thing. What is this? Oh, this sounds wrong. Ignoring the binding element. But I came back from that. That was not possible anymore. So definitely that thing is what's being stored, it seems. In M-sorted bindings anyway. Yeah, I'm an idiot. I knew it. Never mind that. That is the actual thing. Which I just printed. It contains more than just as a vector. I should have searched for this one, I guess. Totally should have searched for this one. No, clearly that's only this one. The bindings key from which mhandle was created. The set index hint that this set layout refers to. Okay, so this clause represents a descriptor set layout and even contains a handle to that. But it also contains the information that was used to create it. And that would be this. and yeah, some link to basically the user-defined object that it corresponds with, I guess. And this is the assert that goes wrong. Okay, and this thing, set layout bindings and flags, actually exists of a vector of descriptor set layout binding, structs, and binding flags, and descriptor set layout create flags, and an array size if at all. Well, these are not super important, I think. They're probably all the same in all cases in my test. Hardly something that matters. Pretty sure I can ignore it for the bug. And these two descriptor binding flags, what is that? Also just flags, and they contain kind of the same thing, right? Update of the binder or not, or stuff. So let's ignore those as well then. At least the descriptor set layout binding, VK. Which contains a binding and a descriptor type, an account, and the flags that I was going to ignore. The count is just an array or not, so it's kind of, well, ignored as well, I would say. So it's, let's say we have no arrays, so we have here a type and where it is bound. And the layout only talks about types. It doesn't say which instance of what it is. It just says it's a uniform buffer or it's a texture, and that's what is bound at that point. And then later you fill in which texture or which uniform buffer that is, but that's not part of the layout. So it says which bindings of a given descriptor set contain which type. Descriptor types. Descriptor type is sampler, combined image sampler, blah 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 blah. The only thing I use is combined image sampler or uniform buffer. Only those two, yeah, at the moment. But still, there's a variation. Then you have to tell which type you are using for each binding of the descriptor set. That would be added by calling this function, that information. And you can see here we do pass an array size if it is an array, and flags, and we're going to ignore all that, meaning that we just add this thing here, descriptor set layout binding, which we just looked at, which just contained that data, the binding number and the descriptor type. Now, of course, if you add something to a binding number 0 and then later on you add something else to binding number 0, something is not right? Unless they are completely different stages, then that is possible. In that case, you would just, one stage wouldn't even know about the other descriptor set. But yeah, the assert finds something that has the same binding number and also visible to the same stage. So this is not an equal sign, it's an bitwise AND. These things are masks. But you cannot have the same binding in the same stage added twice. So if any bit is set in both of them, then that stage or stages would see the same binding being added twice, and that's not possible. So that makes totally sense. I think then the answer to what is the information that is stored. The answer to that is which descriptor type is used for which binding for a given descriptor set layout. Next question was, why is it needed? Well, then we have to look at where the contents of this vector are being used, I suppose. That might be pretty hard to find. It's private at least. So, and here we insert it. So either it is, that's debug code, so I'm gonna ignore that one. It's probably or possibly accessed through this accessor. Wow, even a non-cons reference to that thing. Horrible. It is also used to realize a handle. Which handle? The handle of what? I guess the handle, right? So the descriptor set layout handle. Yeah, this one. So we fill that thing with the information needed to create it, and then at some point this is being called, which then, if the handle doesn't exist yet, it's filled in. But either it just fills, it gets an existing handle from the cache, or it creates one, puts it in the cache, and initialize mhandle. Kind of obvious that then we need it, but let's say it's already in the cache. Then yeah, we only use this thing as a key to look it up in the cache. As in that this contains all the information that makes the handle different from others. It's the same, then it's the same thing. Can use the same handle. The question why is it needed is a bit vague, because obviously we're needed to create a handle. But is that all? I think I should more ask the question, why do we need to restore it? So if a shader is already compiled, and why do we still need this m-sorted bindings and flags? Am I, even for an already compiled shader, going to recreate the descriptor layout? I'm not even sure. Not even sure. I guess I should look at where realize handle is being called. If realize handle is being called at all, in the case that the shader is already compiled, then we need it. This function needs it. Turns out that realize handle is being called just there. Which is on every descriptor set layout in m-sorted descriptor set layouts of a pipeline factory. Which is called, and this is called, and that's so general, I guess it's going to be called always. Void debug comment, so this is the place where it is being called. So yes, that is always called. If it is compiled, then we do a continue here. And then we go to the top of the loop. But eventually we will leave this loop and then we call that function. And this function needs that stuff to be restored. So if only because of this call here to realize the script set layouts that that vector must exist. So that's why we restore it. At least that would be one reason. Let me write it down anyway, because it might be the only answer, or at least a part of the answer. So why is it needed? The answer is the vector. Now let's give it a name. So the bindings and flags is used as key to look up or create descriptor set layout handles. In the cache. Well, that alone is a good reason to need it, I guess. But I want to be complete, so let's have a look at those accessors, where those are being used. Now we're talking about the accessor for these, right? So where's that one being used? And this is used for updating the bindings, the binding numbers. Pipeline layouts. So this is when we do already find the pipeline layout. And then I run over all the descriptor set layouts in the pipeline layout or something like that. And then we adjust the binding numbers so that they match what we have cached. Okay, that's highly dubious. Highly dubious. I don't like this at all. I'm afraid I made a mistake here, which is then going to be pretty dramatic. This used to work fine, but now that I'm using this caching stuff for already compiled things, it's different. I don't think I can just change the binding numbers. I mean, I already compiled the thing. The binding is like completely fixed. So what is happening then here? It sets a binding of binding into the binding of binding out. Where binding in is the set layout in. And binding out is the binding of the set layout out. Which come from realize descriptor set layouts, sorted descriptor set layouts. Sorted descriptor set layouts is this thing. Yep, nobody knows. This code does change into black magic, it seems, but I'm afraid that the reason is that it is wrong. I cannot understand it because it just doesn't make any sense or something like that. I don't know anymore why I could do this. Just change the bindings. I know it's like when I wrote this in the beginning, it was kind of obvious. It's the only thing I remember. But then later on, I made all kinds of other changes and built on top of it and blah blah blah. And now I'm not so sure anymore that we can do this. So hopefully someday I'll run into a bug and then find out why this can't work or something like that. Hello, Candido. Yeah, there's one more line here where it's using it. Just access the array size. Well, yep. Also, a piece of code that is a bit difficult. It has been very, very, very difficult while I wrote it. Please let it just work with capital J and W. I don't understand it either anymore. When I wrote it, it was like wrecking my brain. And then at some point it started working. And now I have no clue anymore how it works or what it does. This has become, the stuff of, I'm not going to touch this. It's a bad thing, I guess. I mean, it's a bad thing unless it's so perfect that it really, really never, ever will need any maintenance. A lot of my code is like that. I just write code that is, bug-free and nobody has ever looked at it again. But I'm not sure about these parts here. The Vulkan code is for great parts a bit iffy. Like, no. There was never a point in my life where I felt, okay, this works and now it's finished. It's more like I still don't understand how it works, but yeah, the test works. So is it now fixed? Apparently. And then usually maintenance is gonna be needed afterwards. That's a bad thing. Anyway, let's ignore those accessors. I'm gonna keep my answer to why is it needed to the vector I'm sorted bindings and flags is used as a key to look up or create descriptor set layout handles in a cache. Next question was how we get the information while pre-processing. Okay, so that would be a linked is in a binding and a linked is a binding number and a descriptor type that we find for a certain stage while pre-processing. Oh no. Yeah, now I need the name of that function, that one function, which I don't know anymore. Yeah, right, that function. Yeah, so that function is called from here, which is called from here. So the pipeline factory. Which is called from here, it seems. Or here. Was a pipeline factory, right? This is the script set layout. Guess it's this one. Pipeline factory. Push back the script set layout binding, which is just inside another one, which is indeed a descriptor set layout binding. So that would be this one or this one. Two. I hate it. Now I have to look at both. Generate descriptor set layout bindings. At least that's called from preprocess, so this will be one of them. And the other one, that's this one. That's the restore, so let's ignore that one. We are talking about preprocess. So what was the question? The question is, how do we get the information while preprocessing? So most of the information is inside that object. Which comes from M bindings. Which is a member of the shader resource declaration context, which is the current file. So we just look for M bindings, then we might see where we add that. M bindings become something. Binding end. I'm looking for a pushback or something. Nobody? Not a pushback. It's a map, so an insert. And bindings. Oh, no, that will do. This is a find debug output, loop over a debug output, loop, debug output, declaration stuff. So that's the only place then. It's being filled with next binding. Simply increment the next number. We start at 0, and then we do 1, 2, and so we pick all the bindings. An update binding is called from there, which is used in. Yeah, so we run into something that is being used in the shader, and then we call the update binding. And no, you cannot use it for every type, at least. Well, every type is part of a descriptor. So yes, every descriptor type, I think, pretty much. Can I say that for sure here at the moment? Like really 100% sure. I think so. Okay, we have here the call. Resource declaration has been generated for a subtype, and we just get binding number. So it goes up, what do you say, it goes parallel to the declaration generation, I guess. Yeah, I think that's good enough. So the answer would be for each declaration, let's call it a shader declaration, shader resource declaration, I don't know, man. Well, that is generated. I need a binding number. And obtaining that next binding number, we also update the m-sorted bindings on flags vector, right? Let me add this. So we go from here to update binding to setting that. We're in bindings is later used in. Of course, we forgot that. Was a loop, right? So not this one. Nou ja, to push back the descriptor set layout binding information. Good enough. The final question I had was, when the data is stored while preprocessing, now when is the data stored while we are preprocessing that when we try to restore it again as a restore. Well, I wrote it wrong, but the idea is clear. Probably, I would say, from here, but we're not sure, right? We're not sure. Okay, let me crash again. So we do this, then you get here. And the question is, when was this added, the data that we just encountered? In the same. But this pointer is different every time. That's very annoying. Very annoying. Don't tell me the map is being moved. This is a set layout. Okay, time for some hacking. Let's say before we crash, we print complete contents. So this is the content. And sorted bindings contains only single element, right? There's only one binding here. Hence one element. So it only contains binding 0, and then the only other thing that's relevant, but we only have fragment shader, it seems. I'm just kidding, but it's always a fragment shader. Hey, we have a flag. We have even an array. But okay, ignoring those, fragment shader binding 0. Which is what I'm also trying to insert. But the question is, when was this inserted? Well, at the same place. So now that the hack is then, I'm going to extend what is stored in this thing and then add an identifier for it. If at all possible. It's probably a VK thing. Arg. It is. Yeah, okay, what's my div at the moment? Nothing much. Okay, I'm just gonna add a standard pair around this, I think. With an int. That should break compilation. Is this a move? That's why this container changes, I suppose. Well, I guess I can keep my IDs during the move. But would be nice to print it, I suppose. So that's a move constructor taking sorted bindings, which is already moved. Let's print this one then. With some kind of this pointer, I also want to know. And this thing lives at probably printed this pointer of that thing as well. So let's say print that. Shouldn't matter. There's another one. Moves two things. So the same thing, sorted bindings is now moved to M sorted bindings, but yeah, we also have add also. Shall I do also an add here? Well, not. Why not? It's kind of the same thing, right? So that would be that one, that one. Binding flags. Now here the binding might be updated. Can't do that. That's what I mean, right? Can't just like that change the binding here. But that's another bug for another time, I think. So let's just print first part of my pair. Wait. Sorted binder, that doesn't work. That doesn't work. It's just a complete vector that we have here. So this must be standard pair. So that's never going to be the case then. Oh, it's never going to be the case. Image. This is for looking things up in the cache. So I have to figure out if the descriptor set layout binding is the same for all of them. How do I compare two vectors with a certain condition for per element? I'll just ask this beast here. It's probably faster. Whoops, okay. Oh, damn it. Yeah. Yeah. Hmm. So I'm using the predicate one, this one. So this first one, last one, first two predicates. What have I begun? So I do think I should have used the second vector for the ID. It suddenly get a bit complicated. But then again, Oh no. I could have known that. Yeah, no. Okay, that didn't work. New attempt. Let's use 2 vectors. It's harder, actually, because now I cannot rely on compile errors. Did I call this IDs? ID or IDs? ID. Bindings ID. Yeah, well, whatever. Should have been binding IDs, I guess. Right. Interesting. Okay, so basically it says that binding 0 fragment, stage flag fragment already exists and was created with ID 10,000. And now we try to insert that again. So now I have to find back where that 10,000 was being used. Thought I was using 1 million, so that's why I used 2 million in the other place. I'm going to change that to 100. IMQ. Yeah, well, who cares, you know. But yes, let's use 20,000 here and then. Probably, no, it's not going to interfere anyway, of course. What I need is that I know where the 10,000 is being used. What is that? Something else. So here, Now it's 10,002. And what already existed there and there. I'm going to start from the top, I guess. So this is where it was created. I hope only once. Of course, it's a static thing. Okay, so here it is created, and then at the bottom I will try to insert it again. But apparently it was being moved, right? It is being moved. Can we follow it? It would have been nice if I added this pointer here, I think. I don't have this pointer. Do I have this pointer on the next thing? Here's something 10,000. What is this? Sorted. This is printing. Sorted descriptor set layout is entering. Realize descriptor set layout. Entering realize pipeline layout. Found in cache. It's returning all over the place, the ID. Trying to find set index hint in sorted descriptor set layouts, or that has contents, blah blah blah. Yeah. I think that means it wasn't moved, right? So these sorted bindings and flags vectors should still be at the same place. But I don't think it is, but that would be equal to having the same this pointer for the object that this is a member of. And I thought that changed. I'm getting a bit tired of this. I think I'm going to do something else. Yeah. Talk to your pieces. Nobody? No? Oh, there we go. Okay, now my plan is, the plan was here, double pawn. If I push this pawn 2 up, he cannot break. You cannot break, meaning if I push this 2, I do nothing. He takes, I take. 1 pawn stops 2 pawns. So this is my plus pawn. I want to exchange everything and then push that one. But I need, for that to work, I need to push this pawn to 2. And I could attack it, and then I want to do nothing. So it must be defended enough. Which means I would have to put my rook behind it, which is of course not going to work. But I could pin the pawn, so I can develop here. And then at least he cannot take immediately. I still have to castle as well. He wants to double the rooks. It's kind of annoying. Then I have to move that one. I can give check. Not good. I cannot give check. My rook is defending that square. Yeah, I just have to go, I guess. My plan is not working. Yeah, it doesn't change anything, you know. I just want to push this one forward, so no, I still have 2 against 1. I can still push this pawn forward under protection of that one. Okay, that's annoying, but you could give double check here, and then I just go away here. Could also go there or check, and then I take it. So sooner or later I have to play this, and now he blocked playing f5. So hopefully now I have time enough to defend my pawn enough to for f5 for c4 not being a problem. Especially when he moves the bishop first now. Could give check, but well, I just go away and then the bishop has to go anyway. I think I'm going to go forward. Could give check there, then I could go back. Well, nah. Oh, like that. I take, he takes my rook. Yeah, that's not what I wanted. This is a good move. Oopsies, not good. Yeah, that totally a good tactic here. Yeah, I don't think there's anything I can do. Just have to take here. There goes my master plan. Oh, there's a knight under attack. And now I lose the knight or the bishop. Okay, it's a usual loss. The usual loss. I'm gonna kill this guy. Rematch. Take it. Take the rematch. No, it doesn't want to play. Oh, okay. The why not move? What opening is this? Oh, it's no opening. Let's go there. Okay. That was a stupid move, I guess. Should have put a rook here. Oh, is the rook even there? We go here, he could take here. Take again, take here, check. Go away, takes there, take there. So unclear. No time anymore. You would take... No, it's not good. Cannot take you. Yeah, just lose this knight, you know. It just takes here and then takes the knight. I lost this game as well. Pose bunny. Yep, that is the one. Just have to take it, I guess. Please take my rook. You're up a piece. You want to exchange. Ah, so lame. So lame. Okay, let's go with this pawn. Oh no, your pawn is attacked. You have to move the pawn. 4 points is a bit much, isn't it? 4 points is a bit much. I can go down and then he wants to put the rook there. No, let's go up. And even more up. Oh, I give away. I give away that pawn. Yep, I had not seen that. So lame, so lame. I should have pushed my pawn. I can give check, I go back, and he takes it. Oh, I didn't. Well, okay, this is good. Apparently, he's starting to feel time pressure. Oh, ha, ha, ha. Again, lame. A maximum lameness here. Really? I don't know what to do. Let's go behind the pawn. Mate. Oh. Now I feel very sad. Okay.